With the simple data pointers that you and I have actually been working with for a while, I'm showing you what's really happening behind the scenes, and they're called runtime pointers. So I'm actually jump to the code real quick. That first statement that you see with int sum equals 0, that's using a runtime pointer. We really don't have access to that. Behind the scenes is taking care of it, but it is still using pointers. And here's why. Is that think of this as the memory address on your computer, and remember that each of the data types that we have a certain amount of space, 4 types for an int, 2 bytes for a short. These are all items that are going to take up space, and that's how we basically, we kind of manage our memory by saying, okay, integer, that's my first variable that I'm going to create a sum. I need you to take 4 bytes of information, and we're going to start with our address of being, 90 million there? And that's going to be our location for the sum variable. So what the values are going to store, they're going to end up being in here, and that's really what this sucker is over here. That's where we're going to have a breakdown of 4 bytes, 4 bytes, for our next variable, which is age. It's going to take up 2 bytes. So notice each of the variables are assigned on a particular address, and that's why they're highlighted a little bit more bold in the rest of those. So those addresses, the pointers, and the names of the variables take care of. That is done behind the scenes and done where you and I don't have to worry about that part. But that's what our runtime pointers have been doing the whole entire time, is it goes, sum? Oh, I know exactly where the value is for that. It's at 90 million, and here's all the content that I need to pull out to get that integer value. Now, these are, by the way, again, the runtime pointers. We're eventually going to start getting into more customized pointers where things get a little bit more interesting, very similar to this. We have the int star, and by the way, the star can be anywhere that you want, meaning it could be right behind the int, could be right behind the right in front of the PTR sum. It can be shifted any way than what you want. Still needs to be a space between int and the variable, but anyway, equals the address of sum. Again, pointers have 2 values, an address or null. That's the only thing it has. Runtime pointers, they take care of that for you, but the physical setup of creating a custom pointer is very similar to what we have here, but obviously more interesting.